let's get into the big topic of open source, something that we actually
And
say at Red Hat.
sometimes we haven't
This
shipped
is so
we
awesome.
are an open culture that believes
actually
in
a big
46
piece
What is that process that a developer, or let's say a
As the
developer,
Kubernetes ecosystem really boomed,
Good morning, good evening, good afternoon, wherever you are in the world. This is the Ask an OpenShift admin live stream. We are part of the Red Hat Office Hours live stream series. We're joined today by our very special guest, Rosemary from HashiCorp. Rosemary, would you like to introduce yourself really quick?
Hi, everyone. I'm Rosemary Wang. I'm a Chief Developer Advocate at HashiCorp, now an IBM company. So, we're just all hanging out.
Yes.
I guess that's the best way to talk about it.
Yes, yes. And it's something that like we've had you on before, and I feel like Vault is like the primo authentication authorization service that most people use within their Kubernetes clusters, and especially on OpenShift. I know my team uses it very heavily, so like, it's something like it's a product I love. So I'm glad to have you back, and it's always fun running into you at KubeCon and stuff like
I
that. So
know.
yeah, pretty
Yeah.
cool. Uh,
Yeah. And it's like, I think the funniest thing with these days with like secrets management is it's becoming more and more popular to actually do some kind of secrets management and not just sort of put secrets somewhere and
yeah,
hope that you found a way to protect them. I think that like at least the folks that I talk to now are not just in the Kubernetes space. There are a lot of developers who are asking these questions like, hey, my organization moved to a larger secrets management service and I don't know how to interact with it, right? It's like a third party API. My applications were never intended to retrieve secrets dynamically. We
hmm
expected to just retrieve them out of environment variables or files for a very long time. And so this has been a really nice shift to see that people are actually talking about secrets management in general and not just saying, I'm going to store my secret in 3 different platforms and try to figure out how to manage them.
yeah. Keep it written down under my keyboard.
Yeah, or on a post-it note. I mean, some
Yeah,
people still do that. They put it on
or
business
email it around. Yeah.
email it around. Oh no, there was someone who actually was doing that the other day. I was laughing with certificates because like we made the mistake of not putting it in Vault or like using Vault PKI for it. So
Mhm.
we were like shuffling certificates around.
Like, I'm sorry. I'm
I'm
sorry.
sorry.
That's awesome.
Yeah.
So for the eagle-eyed viewers out there, you're probably noticing that Sully is not here. Unfortunately, Sully has come down with the allergies from all the pollen in the air out on the East Coast. So it sounds like it's beating him down pretty hard. So hopefully he gets to feeling better soon. Um, and with that, we'll kick off with the top of mind. So one thing that is coming up is April 30th. We have the What's Next in OpenShift. So that's where the product managers from the HPVU or the Hybrid Cloud Platform Business Unit will come out and they'll talk about all the new things that are happening in OpenShift. So it's a good way for you to interact with the product managers of each of the core components that you're in love with, or that maybe you have a problem with, or whatever. Like OpenShift virtualization and some of the stuff with networking and stuff like that. So it's a good place for you to find out what's going into the product and to interact with the PMs to ask some questions for any kind of clarification that you might need. And then something else that's kind of exciting, and it kind of relates to what we're talking about today, is in 419, a service external secrets operator is going to be a tech preview feature, or maybe it's a dev preview feature in 419, which is going to be awesome. So if you use Vault, or if you use any type of secrets backend, ESO gives you a way to template out those secrets, and it will interact on that to that with that provider on your behalf, and then create the secret, instead of using like a sidecar or something like that. So it's a kind of nice service to have. We use it very heavily on my team, and it's awesome. So yeah, I was excited about that when I saw that. I was like, "Oh, this is going to be amazing." Um, and I think that's all I have, other than uh, Red Hat Summit is in May. So everything from now until then is going to start leading up. There's going to be a bunch of build up into Red Hat Summit. I haven't seen a lot of the storyboards on what Summit's going to be about this year, but if I had to guess, if I was reading the tea leaves, it would be very much like it's going to be AI focused and OpenShift virtualization focused. Like that's, I would see those being like the main talking points. Uh, so awesome. With that, Rosemary, I will kick it over to you.
Yeah. I guess I should address the elephant in the room, which is the common question I get in this space, which is like, what's the difference between external secrets operator and Vault secrets operator? Should I be using one or the other? Like, what's the difference? And I'm just going to address it right out because
Yeah.
get enough of this question. So by the way, for those who are in the chat, you can ask any question. I know we talked about Vault specifically, but Terraform is also something that I do know very well. Any of the other HashiCorp products, if you are curious, Console, Nomad, etc., feel free to ask as well. Those questions are open. But with Vault specifically, there's three supported patterns that HashiCorp teams support, right? So the first is the Vault agent injector, which is what Jonny, you mentioned. It's like a sidecar, right? So the sidecar gets injected, it retrieves the secret from Vault and then mounts it into a file volume, and your application retrieves it from a file. The second is CSI, secret store. There is a Vault provider. And then the third is Vault Secrets Operator. And the Vault Secrets Operator is similar to any other operator out there. You define a bunch of custom resources that connect to Vault, and then the operator will inject the secret for you on your behalf into a Kubernetes secret. And so that, I think, is most similar to ESO. So if you are looking at VSO versus ESO, it's a matter of what you want to do. I use a lot of folks who do use ESO are using across many different secrets managers. They're not just exclusive to Vault. And the other thing that is the reason why people tend to use VSO or Vault Secrets Operator over external secrets operator tends to be because they've pretty much gone all in on Vault. And it has the native custom resource definitions for a lot of the dynamic secrets. So just keeping in mind, there's not one way to do it. You can do both ways. It's not that ESO doesn't support dynamic secrets, but if you're looking for something like doing Vault PKI or any of the other fancier secrets engines in Vault that are really dynamic and have certain handling behavior, your application kind of needs to have a little bit more sensitivity to how it's retrieving it from a Kubernetes secret and how it's getting rotated. Vault Secrets Operator has that sort of native support for it. But if you're using many different secrets managers, then maybe external secrets operators for you.
Yeah, that's a great point. And I didn't, that was like the most unintentional segue I ever had. Like that was awesome. Yeah, and I think that the reason why we are so like our big push to use ESO is because we're looking for that flexibility across. We didn't want to lock people into one provider, right? We wanted to provide the flexibility for whatever backend they wanted, and then having the ability to template out the secrets was another one. So
yeah, and it's like I think almost every operator has like table stakes in the secrets management space now has templating, because you don't want to refactor any applications. Like it's not just applications, meaning business applications. Even if you're thinking about deploying something in the Kubernetes ecosystem that has a Helm chart available, you don't really want to be morphing trying to edit and forking the Helm chart or whatever you're doing, right, to accommodate for the secret that is actually coming out of the operator. So templating, I think, is table stakes now. And so a lot of what we're seeing is just this overall pattern, like, hey, we're okay with a Kubernetes secret. We're okay as long as they get rotated on a cadence. We're okay as long as an operator is handling that for us. We just don't want to break the contract between what's being deployed on Kubernetes, reading from that secret, and then needing to do any other changes to the application side. Which is why I think we've shifted, at least in the Kubernetes space, we've seen a lot of people shifting off of a sidecar. If your application is really particular and it does, you really don't want to be giving these secrets, storing them in your Kubernetes secret, people still stay with the Vault agent injector that we've supported. But yeah, it's worth pointing out that most applications on Kubernetes are relying on Kubernetes secrets as sort of contract. So anything that you're looking at from an operator perspective needs to have some kind of templating as a table stakes feature. Otherwise, you can't run a lot of applications that need to use them, use the secrets.
Yeah, awesome. And so we do have a question from rhope9.
Yeah.
It says certificates are fun, but with the new changes voted through the browser forums, with next year's maximum 200 day, the following year max 100 days, and finally a max 45 day certificates. Is this? He's saying that this is the time for like. Have you heard anything about this? I guess this is. I haven't even heard about
Yeah,
this.
I haven't heard about this. So this is pretty neat to know. I know that lately I've been hearing a lot of people asking about certificate rotation and things like that. Maybe this is why people have been asking a lot about it. Because there's been an uptick, I think, in the past 6 months or so of hearing about this. So this is making a little bit more sense. I think a lot of the certificate management that I was learning about, from different customers, they're saying like, we've just had this for 10 years and we never touched it.
Yeah.
Now we're responsible for rotating this on a much shorter cadence, on a much shorter life cycle. So they're looking for solutions to address this, but holistically, it's a much broader change. Like I think someone mentioned to me that their developer group is, I think about like 90% of them will be impacted by any changes that they do with certificates. So yeah, which is pretty bad.
Yeah, that's crazy. And I'm completely brain dead. I'm sorry.
That's okay.
It is our 150th episode. So
congratulations!
Well, like not only is it awesome that you're here, but it's also our 150th episode. And yeah, I made a big deal out of it on the social media part, and then completely forgot about it when we started talking.
You don't have like confetti, going or
No,
something?
no. I don't. I need like the new. I need the new Mac so I can just do the hand signs.
I think I can turn on the reactions. Hold on. Can I turn on the reactions? Or maybe it's too late. I can't. I have to like push buttons to do this. Okay, maybe not. But whatever. There was like a little reaction button that I could turn on for this.
It's okay. It's okay. As long as I had to say something, I saw all the stuff coming out. I was like, oh my God, I cannot believe I forgot that. All right. So Fitu, I'm so sorry if I butchered your name, says, congrats on the 150th episode. Make sure make sure that they watch, and it's helped them learn OpenShift. They just passed their EX280 exam. That is awesome. Congratulations. Fitu, I hope I'm saying your name right. If not, just know that I'm doing my best, and I'm very proud of you. That's awesome. That's no small feat. And then from me says, when will we get Terraform adapted into OpenShift Vert?
Oh, that's a good question about adapted for OpenShift Vert. I mean,
I'm assuming that's a provider, right? Is that
a provider? Is that if you could clarify if it's a provider or some other mechanism you were looking for, like agents or agent pools or something else. Because there are different ways to run Terraform. There are also different ways for you to define Terraform. So there's like, in the Terraform ecosystem is quite large. For OpenShift, for example, you can configure OpenShift with a Red Hat OpenShift Terraform provider. Various ones exist out there. There are modules for you to deploy an OpenShift cluster with Terraform, which I did use. Very cool and very easy. But then there's also the other end of it is like, once you have an OpenShift cluster, there is something called the HTTP Terraform or Terraform Enterprise operator, which allows you to run Terraform by deferring the run to HTTP Terraform or Terraform Enterprise, and that creates infrastructure on your behalf. So there are different ways that we can do. So if you can clarify which Terraform adapted, we can look at it.
nice?
But it could go any of three ways, like a provider, a module, or something else that actually runs on OpenShift.
All right, and so you're saying that you've deployed an OpenShift cluster using the Terraform provider? Is that what it is?
Yeah. So I can show the Terraform itself. But yeah, there's a module out there which was really convenient. For those who are not familiar with Terraform defines infrastructure as code, and you can use it to deploy any kind of infrastructure that you want within reason, as long as there's something called a provider for it. So a provider is, you can think of as a Go server that is written to connect to a third-party API. So that could be a cloud service provider. That could be, Red Hat. It could be HTTP, right? For example. So anything that has an API, you could write a provider to connect to it and then use Terraform to provision and configure resources against it.
That is awesome.
Yeah. So it makes it, if you have not explored provider development, it's kind of fun. It's like people have done it for a lot of different things. Dominoes, you could do it like, as long as there's an API and has create, read, update, delete, you can write a Terraform provider for it. So there's one that does exist for if you're deciding to do like, if you're provisioning an OpenShift cluster, right, through HTTP, various things, right, is a module that's also available too. So not only is there a provider, but the team has made it really easy for you to provision the cluster with all of the minimal parameters you need using a Terraform module. So it kind of bundles it all together for you.
That is awesome.
Yeah. Oh, I see. We have a clarification. We're virtual infrastructure inside of OpenShift. Okay, yes. So it depends on this. Okay, so the clarification is, will we be able to use Terraform to create virtual infrastructure inside of OpenShift? I'm not as familiar with virtual infrastructure inside of OpenShift. Is that a possibility, Johnny?
I mean, this is where like I think as long as I think as long as you can talk to the API, like that's again, you'd have to have a provider that would be able to create that infrastructure, so additional networking and stuff like that.
Yeah.
I can reach out to, well, if Sully were here, this would be a great question for him because he's on the OpenShift virtualization product team. But yeah, so from me, I will find out. If you want to email me, my email is up here. It's johnny@redhat.com.
Yeah.
If you email me, I'll make sure that Sully gets it, and then we'll make sure that the right
Yeah.
people inside get it. We get it answered.
Yeah. A roundabout answer to this is that if the virtual infrastructure has a custom resource definition, right? So whatever virtual infrastructure you do want to define, right? I know the ecosystem, the Kubernetes ecosystem is looking at how to do like sort of a common infrastructure definition, right? That's captured as part of a custom resource definition. If there is a custom resource definition that you want to use to create infrastructure, then yeah, you could use Terraform, the Terraform Kubernetes provider to define the custom resource definition and provision the resource as a custom resource definition. But then that implies that there's another controller or an operator out there that will provision that infrastructure for you. The common one that I see is the folks using the HTTP Terraform Enterprise, the Terraform operator, just call it what it is. But and basically what people will do is their platform teams will create a Terraform module. So a good example of this might be, give me a database, right? And the database will also configure, the database not only has the managed database, but it also has, connections to Vault, right? So that way Vault can issue dynamic credentials for it. This is all captured in one module, and someone will deploy the Terraform operator, and then they'll deploy a custom resource definition called a module. And what it will do is it will create a Terraform, HTTP Terraform workspace, and then provision the infrastructure using Terraform for you, right? Using that module reference. So what that does is basically offer you the ability to provision infrastructure, real infrastructure, or whatever infrastructure you want through Terraform, but you use a custom resource definition in Kubernetes to do so. And so we have a number of folks who do that because they have platform teams that build these modules, but development teams themselves want to be able to consume and pick and choose what kind of add-ons they want for their applications.
Awesome. And we have a question from Anthony, and it says, does HashiCorp have, I keep saying HashiCorp, and you were saying HashiCorp. So is it potato? Like,
HashiCorp, it is HashiCorp.
Okay.
HashiCorp, because it's from the Japanese root. So yeah, HashiCorp. But it goes, most people pronounce it however they choose.
All right. Well, I will do my best to say it correctly then. Does HashiCorp have something that compares and contrasts the pros and cons of the different ways to connect with Vault, the CSI, ESO, and VSO? Like, so is there a table or a chart that Oh, and you
Yes,
are all over it.
I linked it so that you can post it to the chat because I can't properly figure out how to highlight it right now. But in Restream, but so there is a blog to Agent Injector, CSI Provider, and the and VSO, I think. One thing that I would also say is not on here is ESO. There's no direct comparison between ESO VSO that I've found, but you probably will find a community member who posted something about it. But like I said, the main difference between the two is going to be what your use case is. And if you are committed to using Vault and you have a need for some of the more complicated secrets engines in Vault that do really very specific things about dynamic secrets, you may choose to use VSO. If you're doing just static secrets and key value stores, you may choose to do ESO.
Awesome. And Roderick asks, how do we create the partitions or mounts using Terraform? And for me, for my own personal edification, I needed to know like where he was talking about or where they were talking about. And the response was from or within a provision VM. So how do you use Terraform to create a partition or a mount?
You know what? Let me pull up an example for you on this one. Yeah, let me pull up an example.
Under shared screen?
Yeah, on my shared screen.
Okay, let me open
I'll
this
pull
up.
up an example of this. Okay, so there's a couple ways that you can think about doing this. But the biggest thing that I would suggest is that if you want to do it all in Terraform, which is one way to think about it, if you want to do it all in Terraform, you have to do a combination of two things, and this is going to apply to most cloud service providers. Now, if you're thinking about virtual machines in other environments, right, on premises being one of them, this is going to depend on your deployment as well as your hypervisor and basically what your automation is going to be on premises anyway, right? So that sort of depends. But if you're talking about a cloud service provider, this is going to be, I'm showing AWS, but you'll also see this across many other types of cloud service providers as well. The important thing that you're going to need to do is twofold. And I'm going to make sure that I have pulled up the correct one. This is just an example. I don't worry about boundary. That's not really the point of this. If you're curious to know about what boundary is, let me know. But this is basically a Terraform, a very large amount of Terraform to deploy boundary, which is another HashiCorp product. But the thing that you're going to need to do for a provision VM is twofold. The first is you need to define whatever device you're mounting to the provisioned virtual machine. So in this case of AWS, I need to define an EBS block device. That's part of the AWS API. Any other cloud service provider also tends to have a volume or a block device or some kind of definition you include. So if you're not familiar with Terraform, you'll have a resource, which is the API resource, and then each of these attributes are like specs as part of the API. And so EBS block device is one of those attributes that you can define through AWS API. So the block device you need to add as an attribute. And there's this second portion that a lot of people miss. Not only do you have to define it for the provisioned virtual machine, you also have to define where in the machine itself, where the volume is located and how it's being mounted. So it's not quite so simple to say like, okay, I'm going to create this block device or I'm going to create this volume mount and then mount it. You also have to define in your user data where exactly you've mounted it, as well as, you have to configure it as well, which is, kind of the downside. So you'll notice that there's this large amount of user data here that I have to, a user data script that I have to create. And some of this includes a reference to these mounts that I've created. So in the case of AWS, you have to go in and you have to find the correct device identifier. And then you have to say that is indeed a file directory. I'm going to make a directory there as well as mount a file directory. And then I have to change my user permissions in order to use it, for my process to use it. So in terms of the mounts, right, you have to just be aware that there's a two-step process in Terraform. The first is the actual definition from the cloud service provider or the virtual machine definition perspective. And then the second is the user data has to configure that device or that mount or that partition correctly. the different ways that you can think about doing this, right? You could say, I'm going to provision the typical way people do this. They're going to provision these devices or the mounts themselves outside. We're using Terraform as part of the initial definition of the virtual machine. And then they'll use something like Ansible to configure and put the correct permissions on that mount within the machine after the fact. And so that is something from an integration standpoint we're looking at putting together more closely. So the sort of a seamless experience between Terraform and Ansible is sort of in progress right now. But for now, if you're looking at it in your own virtual machines, just keep in mind there's two parts to this process. We've made a lot of mistakes along the way.
Oh yeah.
You can't use this device. You can't use the mount unless you actually configure the correct permissions on it. So that's why you do have to do the second user data step.
Awesome. Yeah, I remember going back. This is taking me back to 100 years ago when I was doing this, and I think what you said there makes perfect sense, right? It's like in a normal virtual machine, you get your root file system, and that's part of your normal base deployment. And if you wanted to add a disk, right, that disk isn't really, it's just there. It's just available to the system. You still have to put the file system on it. There's more that you have to do to it. And what you're talking about is like, hey, you're telling AWS or Azure or GCP, add this block device. It's raw. There's nothing there. So you still have to initialize it and then put the file system on it and then mount it and do all the fun stuff after the fact.
Yeah.
And I think the way that we did it is we didn't use user data, but we did Ansible. So
Yeah.
potato, right?
Yeah, and the thing is, you probably should be using Ansible. I mean, like, I don't like using user data that often. I mean, I do this for demos so that folks can just get it up and running. But long term, if you're managing these resources, right, you don't really want to be doing everything in user data. Please use Ansible.
Yeah, and this isn't meant to stump or anything like that. But like, is there and I might be misremembering too, but is there like a file size limitation on user data? It feels like there's almost like the config map thing where you have like I think it's like a meg or whatever.
Yeah.
But I feel like there's a limitation to what user data can actually do.
Yeah, and it's also not terribly easy to debug or rely on either. Like, as much as we try to move everything to immutable images, right, for virtual machines, it's like we're trying to get used to this idea of baking as much as possible into a virtual machine image so that there's less to start up. Unfortunately, people are like, you still need to configure things on startup, right, for a virtual machine. And user data does have a limit. I don't remember exactly what the limit is, but in terms of even debugging it, it can be a real challenge.
Okay, awesome. And then this brought up. Okay, I'm sorry. This is my own personal stuff right now.
Yeah, it's okay.
So with you guys coming over, with the Terraform and Vault, is Packer also going to be something that's kind of like bundled into all this, like with the merger?
Yeah, Packer is included in the mix. For those who are not familiar with Packer, Packer is an image builder, or it's an image bakery tool. I mean, I guess, there's a different way you can.
Yeah, I like both.
Yeah. Image bakery tool. And it is actually it's used pretty significantly for building machine images across many different cloud service providers, many different virtual machine platforms and things like that. And so that is something that is coming over. There's no real direct integration right now, just because most of Packer is pretty much building virtual machine images. But there is a possibility to do more integrations with. We have a registry called HCP Packer, and it allows folks who are using Packer Community Edition to register and track metadata for their virtual machine images more efficiently across a lot of different cloud service providers and things like that. So if, like, for example, you're in a really large organization and you want to track the artifacts of these virtual machine images that you're building across many different regions and across many different cloud service providers, HCP Packer provides a lot of this metadata for you to track and make sure that these things are all correct. And by extension, it allows you to also connect to HCP Terraform or Terraform Enterprise. The folks who are using it for machine image management. So once like a security rolls out a new golden image, then it automatically triggers a workflow to rerun the Terraform and update the images and things like that.
Yeah, I love Packer. I think Packer is probably like one of the most underrated tools that are out there. Like, it's been so awesome. And back in the day, I used to work in a very security conscious government organization, and so like, you know, one of the big things with them is STIG, and that's having multiple file systems. So you'd have like var and home and user and stuff like that.
Yeah.
And in a cloud image, it's just a flat root file system, and then you have to add a disk and then do other stuff with it. It's
Yeah.
painful. And
Yeah.
Packer was a way to like get around that, where you could actually build the image out with all those different root file or all those different file systems enabled. I love Packer. I think it's awesome, and I'm really glad to hear that's coming with it. So
Yeah. It's like it's the quiet one that is used behind the scenes for a lot of anybody who's building an image, right? It tends to be using Packer to do it and to distribute it across many different repositories, image repositories, and things like that.
yeah,
And so it's, I think it's been a good thing to see sort of its resurgence, right? People are becoming more and more aware that they do have to build their own images, especially to not only improve like the speed of startup, but also from a security perspective. I hear more and more
yeah.
people who are embracing image building.
Yep. And then like, and we have an image builder as well. And like, I'm sorry, Red Hat, but like I haven't used it that much. So like I'm much more versed in Packer than I am with the Red Hat image builder. So I'm sure they probably have a lot of like parity between the two. But my experience with Packer was I was able to build KVM images or I was able to build images that I could use in KVM and OpenStack, and also VMware, and move them around and stuff like that. It was just super flexible, super easy to use, and I was able to hook in Ansible and do it's an awesome tool. So I'm glad.
Yeah.
We do have a question from Munir, and it says, "What about storing keys and certificates as secrets inside a vault, which are generated by Cert-manager?"
I'm guessing this is like Kubernetes Cert-manager. So assuming that's
Yeah.
that's what we're talking about.
Yep.
So the reverse is true, but not this particular question, if that makes sense. So the reverse is true. You can use Vault as a source for Cert-manager. So you would set up Vault as use Vault with the PKI secrets engine. The secrets engine, PKI secrets engine generates certificates. You can bring your own offline root CA. You can generate a ton of intermediate certificates, things like that. You can define intermediate CAs if you need to, using Vault PKI, and then you can set it as a source for Cert-manager, and Cert-manager can use reference Vault in order to issue certificates in the cluster. The reverse, however, is not quite there. So in order to do the reverse, right, if you have Cert-manager and you have certificates already being generated, those are things that you will have to manually port back into Vault, right? It's not going to be, it's unidirectional, right? Vault being the source of truth, and then as a reference for Cert-manager. But, in order for you to do that kind of porting of existing certificates or certificates generated by Cert-manager and storing them back into Vault it's kind of challenging, right? Partially because it's going to depend on how you're setting up Cert-manager, what those certificates are being issued for, and then how you're going to divide them all in Vault itself, right? So folks that I work with typically are looking for using Vault PKI to Cert-manager, maybe not necessarily the reverse, which is Cert-manager already generating and then bringing them back into Vault. But there are people who I do know who are using Cert-manager, and they want to port them into Vault. And what they'll do is they'll actually copy some of those certificates and just put them as statically in Vault, and periodically synchronize them. But
Okay.
It's not a great pattern that I would endorse, just because it does require additional work for you to audit what certificates are being issued, and then you have to backport them into Vault.
And then you put a person in the middle, and you're relying on,
Yeah,
there's
and
no
it
way
would
to
have to
automate
be
that.
done into like key value store too. It's which kind of is, it's key value store. I mean, it's keys and values.
Yeah.
Yeah.
Tolga asked, again, apologies if I butcher any names. Tolga asks, "Any offers or news about Vault being integrated with OpenShift Platform Plus, because Vault licenses were more expensive than OpenShift licenses?"
I'll bring that as a question. It's an interesting thought. Right now, we do have HCP Vault Dedicated, which is the cloud platform Vault. It's not the same as hybrid cloud platform. It's HashiCorp Cloud Platform is like the same acronym. And I was like looking at it, I was like, no, they're the same acronym. HashiCorp Cloud Platform Vault is a way for you to use Vault without the licenses, right? And so there's, I would say there's not a direct integration between HCP Vault and OpenShift, but we have Helm charts and operators that are certified on Operator Hub. So we have a number of Helm charts for Vault and Terraform, and I think Console as well, that are certified for running on OpenShift. We also have operators that run for OpenShift and are on Operator Hub. But the enterprise license itself, currently, I haven't heard any plans, but I'm certainly happy to ask and bring that as feedback.
Yeah, and I can do that on my side too. And Tolga, just so you know, like I would say that is still pretty far down the road. Like Rosemary and I were talking about this before we came on the stream. Like there's not really a lot of information as far as like how it's all gonna shake out in the end. Like we don't know what it's gonna look like a month from now. Maybe Rosemary has a little bit more insight. I definitely don't. But like HashiCorp Vault being part of the OpenShift platform plus, if anything, it would be part of the OpenShift product suite, and then you would just get that with OpenShift. But again, I don't know how it's going to be divvied out or shelled out, or like what the integrations are going to look like.
Yeah, I mean, and I think that's also it's worth making. It's worth documenting at least that there's an interest to do it, right? Because some folks do want their Vault clusters on OpenShift. Other people would prefer that they leave them completely external and secure them in a completely different environment. So, it'd be good to also hear if you have any thoughts about where you want to be running this Vault cluster, if it makes sense to include that as part of OpenShift or not, or if it's just the licenses themselves, right? So,
yeah, awesome.
Mm-hmm.
And Tolga, again, feel free to reach out with like any suggestions, any questions, stuff like that. And Rosemary and I will at least do our best to get them asked in our in our lanes.
Yeah, exactly.
So Manir asks, is there a way to store secrets in encrypted mode in a init container via Vault Injector, which was stored in Vault?
Oh, so that's a very good question. There is not, short of some fancy maneuvering. Okay, so there is a way to do this that I've had some folks mention to me, but there's a performance there's a performance disadvantage to doing it. So there is not a way to do it natively using the Vault Agent Injector. So for those who are curious, like the Agent Injector is going to create a file mount and then write the secret in plain text to the file mount, which gets mounted as a volume on the pod, and the pod can consume the secret from that file. And that's how the Agent Injector works as a sidecar. So in terms of like what is a secure method? If your application is trying to be particularly secure and not expose the secrets at all, this is one of the more ideal ways to do it, right? So the question is, can the Vault agent encrypt the secret when it gets written to the file? And then the application, unfortunately, would have to decrypt it, right? So that is not natively supported in Vault Agent. However, there are people who do this. And I don't know if I would recommend it, just because it does introduce a little bit of latency, a little bit of a performance hit, right, in terms of how your application gets the secret. So the way you would do this is that Vault Agent has templating capabilities. And in this templating capabilities, there's a command execution where it's like anytime the secret changes, right, you can do something to it, right? And so what people will do is that they'll write out the file and then they'll encrypt it using Vault Transit and then write it to a new file. And there are ways that you can template out even like an encrypted, right, payload as well. So what they'll basically do is use secrets engine to encrypt the payload onto a file. And then the application is responsible for decrypting the secret or that payload before it starts up or before it uses it. Is possible. I've maybe had 1 or 2 people tell me that they've done this, and it was very painful. Partially because they didn't, partially because, it was also on the application to have sufficient permissions to Vault to decrypt the payload, right? And so the result was like it was a bit of a performance hit because you now have an application that is trying to decrypt the payload. You're encrypting the payload to get the secret onto the file, and then now you're decrypting it by Vault, by application, which needs access to Vault. So the easier way to do this, or the more ideal way to do this, I would say, is like if you really want to be extremely secure about this payload, is have the application just call Vault directly. And the reason why I say this is that it is encrypted in transit. The secret itself is encrypted in transit, right, on the way to the application. It means that your application is going to be Vault aware. It's not Vault agnostic anymore, right? Because now your application has to make an API call to Vault.
Mhm.
But you also don't have the encryption and decryption sequence and the latency that you introduced, right, by having an agent encrypt it and then you decrypt it on the application side.
And that process would happen every time the application has to access that secret, right? So like if you have an application that's constantly doing it, it wouldn't keep it open, so it's constantly
Yep.
okay. Yeah, that would suck.
Yeah, it would. And then it's like so basically the problem didn't come out until after the application was restarted, which happens on Kubernetes, right? Things get rescheduled, pods go in different places. And so then they would just you would have to wait for a very long time for it because it's making at that point 4 API calls, right? One to authenticate to Vault. The second, unless there's like a Vault token cached, so then maybe it omits that. But when on startup, it authenticates to Vault, and then it retrieves the secret, and then it encrypts the secret, and then the application then decrypts the secret. So that's 4 API calls to Vault, right, on one sidecar, basically, which is also a problem, right, in terms of how many times you're calling the Vault API. Vault API can handle that, but whether or not your servers and your load balancers can handle that is a whole other issue. So it's not really ideal. You might as well just bypass the process entirely and just make your application Vault aware and just make a call directly to Vault specifically. It just kind of omits the process, the need for a sidecar, but it also just cuts out anytime you write the secret to a file. Instead, if your application is calling Vault directly on startup, it's going to just get the payload in memory.
Awesome. And rhope9 says that this would probably make more sense with confidential containers. I've been meaning to dig into this. Like this is one of those things that's been on my list and it just keeps getting bumped down.
What is this?
Confidential containers. It's the short name is Coco, which is obviously kind of cool. But yeah, don't even get me a line. I'm not even going to try to explain it. But it's basically like a sandbox container. But it's way more than that. I'm oversimplifying it 1,000%. Esports Nexus says, please make videos setting up Argo CD for continuous deployment on OpenShift. 100% we can do that. If there's another live stream that we do called Get Up Sketch of the Galaxy, where we do go over a lot of these things with Argo CD. And my team specifically does a lot of work with Argo CD and OpenShift. I would be more than happy to do an episode on that, or maybe bring somebody from the team and let them do a demo of the stuff that we're doing. So Esports Nexus, we can definitely make that happen, and we will make that happen. Just give us some time. Yeah. So this confidential containers thing, it's something that it's been coming up quite a bit lately. It's been a thing for a while now, but it's really starting to get some traction, and kind of like when we first started, you were talking about how like now everybody's talking about secrets and everybody's finally like aware that, hey, there's something with this, I need to do something about it. And now here's all these toolings, and now they're thinking about it early on versus like being done with the project and then like, oh crap, how am I going to like integrate all this stuff? And I think like confidential containers is another one of those evolutions where it's like, hey, we need to have this ability to do this in an isolated environment. And like they're like, yeah, that's cool. And now it's like, okay, no, we actually need to be able to do this in an isolated environment. And that's what Coco is. But it's way more than that. It's awesome. And like the things that I've seen on it are really cool. It's just a matter of I haven't informed myself or gotten myself up to speed enough to talk about it
Yeah,
with any type of sense.
I think it's also like it's helpful. You don't know you need it until something happens.
Yes. Yeah.
I think that's part of it too. I have to look into this as well because I've never heard of it, so I'm curious now.
Yeah. It's like the I hate to keep doing this with SolarWinds, but it's like the SolarWinds hack, right? When all that stuff went down, like everybody's like, "Oh crap, security matters." We there's all this stuff like the supply chain, like there's all these things that matter,
Yeah.
and like when it became a household topic, it was like, all right, well, people were actually doing it, and now it was a whole thing for a while, and it's cool to see because like when coming from that industry or coming from that field, and then going through that pain early on when nobody cared about it to see it evolve into being, first class citizen in conversations at, at some of these consulting engagements is pretty cool. So
Yeah, yeah. It's I'm looking at it right now. Thank you for the link from chat because I was like, yeah, I've not heard this. So this is pretty interesting. I will have to look at it a little bit more because I do hear there's increased interest that I've been hearing about folks who want to encrypt payloads, right?
mhm.
Um, I hear it just from the context of, folks saying, okay, I need something that will help me encrypt my payload. I don't want to hold encryption keys left and right, right? I don't really care about that. I just
Yeah.
want something that does it for me. And that's why Vault has come up a lot, specifically Transit Secrets Engine. But then, I've seen a lot of folks who are more and more interested of Transform Secrets Engine because they're dealing with confidential information and they want to encrypt it more proactively, right? And keep certain formats. They also want to keep, they want to do masking. They want to do all of these more important data protection techniques, and they haven't thought about it since. And so it's been a resurgence, I think. And yeah, security should always be a design goal, not an actual.
Yes.
Yeah, exactly.
Yeah. Great point, R Hope 9. That's a great point. And and this is coming from the guy that used to fight with my security team all the time. Like I was probably the worst just because like you're trying to implement something and like it's like they don't understand, and then you're trying to explain the value and like, hey, this is why we need to do this, and it's like it was a constant battle. So
Yeah,
yeah.
exactly. Make it easier for everyone. It also
Yes.
helps now that I think we've standardized on like codifying a lot of
Mhm.
configuration as well. I hear a lot about this in the Terraform space. Like, how do I make sure that I have a secure infrastructure configuration, right? A developer who's provisioning a database does not care.
Right.
They don't care. Like, like someone's not going to care if it's like an admin username. These things just don't really exist top of mind. And so being able to standardize and template out the things that you need to provision has also been really helpful from a security perspective as well. You can do the secure configuration right as part of the design of the template rather than after the fact going back and securing it.
Yeah. Yeah. And I'm glad you brought that up. You were talking about the Terraform operator earlier.
Yeah.
How does like in normal Terraform, the state is local on your file system. So how
Yeah.
does the operator maintain the state? Does it connect to like a bucket like an S3, or is it something like within the operator, like through a config map?
Yeah, so I'll show. It's not working right now, unfortunately. So this is this is what you get when you do attempt to do a live demo
Yes.
too quickly. So the thing that is happening with the way that the operator itself works, which I'll pull up, it's connecting to HCP Terraform or Terraform Enterprise, and so you'll notice that effectively we have this kind of like project structure. And so what it will do is connect to HCP Terraform, and HCP Terraform stores the state. So a good example of this is like this workspace was created with the operator. And the workspace includes a state space, right? This is the only place in which the state is stored. We currently don't support the other backends for Terraform for a couple different reasons. And part of the reasoning is that when you defer the run, you're deferring when you're running Terraform. It's not running Terraform in the OpenShift cluster. It's running Terraform on the insto. You'll see a run come up that's like oh, it was triggered by API, and the run will happen within HTTP Terraform. And yeah, there's a couple different reasons, right? Because we originally tried to design this operator to run Terraform in Kubernetes, but there were a whole host of issues with this. Like, it turns out, like, between Terraform versions and then reconciling state and all sorts of confusing things, it was just very confusing for everyone to try to design. And at the time, there was a bit of like there was a constant race condition going on. It was really hard to make it idempotent. Basically, it was hard to make the operator continue to do this run, right, without kind of like constantly cycling with a Terraform agent that's like running in the OpenShift cluster, so or the Kubernetes cluster. So the result is that it defers the run to a more stable place, which is specifically agents that are designed to run Terraform. But for a large enterprise that Terraform operator Kubernetes, for a large enterprise that's doing this, though, a lot of the times we find them provisioning agent pools. So there's an API reference. What they'll do is, like, the control plane exists in HTTP Terraform or Terraform Enterprise, but they want to provision an agent pool within Kubernetes. From a security perspective, they want to be able to manage these agent pools themselves, because there may be internal that from a networking perspective, there's internal connections that they want to be making. And so we do have a CR, a custom resource definition for someone to manage the HTTP agent pools, and that will allow you to run Terraform in your OpenShift cluster if you want to. And then you would still use the operator to defer the request to HTTP Terraform or Terraform Enterprise, and the control plane will then send the request down to an agent pool. And then you can run it within your OpenShift cluster. So that's kind of the roundabout way that this kind of works. But it basically prevents, because Terraform tends to run synchronously, and Kubernetes operators need some asynchronous status reporting back. It becomes a little bit of a challenge to do it just all within an operator. So the result is that it's easier to defer to a control plane somewhere else, and then make that control plane be sort of the orchestrator of long-running Terraform applies.
Okay, so just for my sanity, is it like, it's like an inverted GitLab runner where you execute the run on the GitLab instance, and then it will go out, it'll deploy a runner pod to the OpenShift cluster, do its thing, and then report back. In this case, you're saying do a Terraform run, it's going out to an HCP instance, running all the stuff there, and then reporting back to the cluster. Is that kind of
exactly?
okay?
Yeah.
Okay.
Yeah, exactly. So it's a status call. It's an API call at the end. It's all API calls at the end of the day. But for those who do want something that's more like, oh, we want to control what Terraform is running in my OpenShift cluster, you can also provision an agent pool similar to the runner, right? An agent pool that runs Terraform for you, but that control plane, you're still making an API call to HTTP Terraform or Terraform Enterprise.
Okay. Yeah. So if you have like isolated network, you could still run everything in house without having to worry about calling home or anything.
Exactly. Yeah.
Okay. Cool.
Yeah.
Yeah, that's neat. There was another question that just popped in my mind, and I can't think of it, but it'll come back to me. And so I'm sorry. Does HashiCorp have an official or community channel in Slack?
We do not have a Slack. We do have discuss.hashicorp.com. So that is our forum. We have various folks who are answering. So you'll find, like, mixed. Sometimes it's engineering, sometimes it's product managers who are going to be answering questions on there. But that's where you're going to find a lot of our community. We also have our ambassadors and many other different community members who answer questions on there.
Yeah, and one thing I'll say about just the Hashi ecosystem in general is, like, it is huge. Like, there are so many people that participate in it. Like, so many people use Terraform, Packer, and like there's blogs and all kinds of stuff all over the place. That, like, it is an awesome community, and it's literally the reason why I was able to pick up like Hashi over like a weekend. Like I was on a project. They're like, we want to use Terraform, and I was like, cool. So I just started banging away on it. And yeah, it's it's a pretty incredible thing. So
Yeah. A lot of people are happy to help too. And they'll tell you all of the mistakes they've made so you don't make the same mistakes too. So
yes, yes,
it's really helpful. A lot of the folks are really helpful. And I think it's also, if you have integrations that maybe you can't find or it doesn't exist, or you're also not sure if there's something that is official for it, a lot of the community also contributes different integrations, whether it be on providers or modules and more. And so you'll usually find something or an example of someone doing something
yeah.
if you don't know or you don't have an official integration for it.
And this is a like a loaded question, I think, but like, do you know, has the integration between like Terraform and Ansible gotten better? I haven't used it in like a good 2 years easily. I mean, it's probably been a little bit longer than that, but like, not that it was that difficult before, but you'd have to call in like an Ansible playbook and do some stuff. Has that integration between Ansible and Terraform gotten easier, I guess?
It will get better. It's not easier right now. It's still
Okay.
sort of the way it is, which is like very, in my opinion, a little bit of a brittle workflow because
Hmm.
you have to run Terraform, and running an Ansible playbook is, you do have there's an Ansible provider
Hmm.
that allows you to do it, but to a certain degree, it's not a seamless experience, right? Really what it comes down to is Terraform was made for automation. It's not made for orchestration. And there's a nuance, right? It was made for automation and not for orchestration. And so I think the biggest effort right now in terms of making that experience more seamless with Ansible is to think about how do you want to use Terraform as an orchestrator, as something that is sort of the event that drives the secondary event, right? And the next event after that. There's back when Terraform was first getting adopted and we were starting to think about using it more and more, most people were just struggling with automation. Like, how do I
Hmm.
even provision something in a cloud service provider and do it in a repeatable way? No one was really thinking about larger infrastructure orchestration across many different systems, bridging that gap from like provisioning to configuration management. Was just like, we'll hack it together. And so that's right now, it's still, we'll hack it together, we'll figure it out right now. But the thing we're looking at right now is how to make Terraform a little bit more seamless from an orchestration perspective. So there is work that's going into building out Terraform a little bit so that it can actually make a direct call to run an Ansible playbook rather than hacking it together with like
Yeah.
providers and things like that.
Yeah. No, that's interesting. And like the way that you said that, I think I've always thought about it the other way,
Yeah.
right? Where it's more of an orchestrator versus an automator, but like it makes sense when you say it like that because and that makes sense why we'd have problems with I don't want to say problems, but like why it's not a smooth transition from one to the other, right?
Yeah, yeah. And it's like automation and orchestration solve very similar problems.
Hmm.
But the thing about automation the thing that Terraform, why in some ways Terraform is really good at automation is that it forces you to think about four very specific behaviors: create, read, update, delete. And those four very specific behaviors introduce very predictable patterns.
Hmm.
Orchestration, however, encompasses a lot of unpredictable workflows and unpredictable patterns that have to be flexible. And Terraform, not so great at that, right? Like if
Right.
you've ever tried to run Terraform apply and then you realize like, oh, this is completely out of order and it doesn't work, it's partially because it broke this expectation of create, read, update, and delete. So that's why I think now we're hearing more and more people who are like, well, we're using Terraform for a lot of automation. It does it really, really well. It does it very predictably. We want a little bit more predictability in these larger use cases where we're addressing bigger workflows.
Yeah. Yeah. And I think that is an excellent explanation, right? Like that the being because you're locked in a box on what it's meant to do, right? Not locked, that sounds really rigid, but like it's very structured. It's I know what I'm supposed to do. That's what we're gonna do. This is how we're gonna
Yeah.
do it. And the stuff that we were trying to do is we were trying to like, okay, and then do this and then do that. We're trying to like patch these like workflows together, right? We're trying to
Yeah.
like some pre-build, some build, some post-build, and then deep config type things. And yeah, it was you had to be smart about how you were going to um basically like structure everything out. You know what I mean? Like it's like we're gonna start here and then we're gonna break off. And it was cool because we got it done, but it just took some time to figure out. So
Yeah. Yeah. Exactly.
What is the, and this is from Jefferson, what's the biggest difference, my God, I can read. What's the big difference about Ansible and Terraform?
The biggest difference is Ansible is what's considered primarily a configuration manager. Now, you can do a lot of things with Ansible, including provisioning resources if you really wanted to. But Ansible is particularly good at provisioning configuration on a specific resource, like a virtual machine or a different resource. Terraform, on the other hand, is made for automation and configuration related to provisioning of resources or just generally updating of resources. And so if there is a larger API that is allowing you to make a change on a set of resources or dependent resources, Terraform is very, very good at that. But what it's not good is going into a virtual machine and knowing what is the current state of the existing machine and then making sure that the configuration of the machine matches what you're expecting, right? It was not made to go into a machine. It was made to work with an API. So if you have a device, there's a little bit of a weird line. If you have a device with an API, theoretically, you could have Terraform orchestrate against it, right? There have been times where like I was playing with Terraform orchestrating a network switch, right? And that's because the network switch itself has an API, HTTP API available for Terraform to do this kind of work. And very predictable behaviors, create, read, update, delete. But it's not, Terraform is really not made to do configuration management. So most folks who are going into a network switch are looking at, patching, making patches, they're making changes directly to it. They're approaching the configuration itself right on the box. And so Ansible is much, much better for that.
Yeah. And one thing just to add on to that, because I don't know if I can actually add any real value beyond what you said, but Ansible does that manage state out of the box, right? If you're using the Ansible CLI and you're building virtual machines in AWS or EC2s in AWS or whatever cloud instances you're using, it doesn't manage that state where Terraform does, right? So Terraform will say, hey, look, I've already provisioned this resource. And so it makes it idempotent. And so it makes it to where I can rerun that Terraform apply. And as long as nothing is changing, no changes get applied. Where Ansible, it'll go out and it'll make sure it'll try to create it, but if it already exists, then it'll skip it. Where Terraform is already saying, "Hey, we're good to go. Like, let's rock and roll." It's managing the state.
Yeah,
And
there's
that's what
no
makes it
side
awesome.
effect to state too. So like it's nice about, their state is great in a lot of ways. It means like you can detect drift, you can detect a lot of things. But do you really need to detect drift on the virtual machine? Maybe, maybe not. Sort of depends.
Right.
You are more likely to need to detect drift on virtual machine attributes or like security groups, right? That you've provisioned in your cloud service provider. So state has some very powerful implications, and at the end of the day, that you can use state in a very powerful way to orchestrate between the two. So that's why most people end up using both.
Yeah. Yep. And I think that's why I honestly like we came up with a pretty good workflow, but it just took some time to get there, and it was pretty awesome.
Yeah.
So, well, Rosemary, we're at the end. It's 12 Eastern, I think. Yeah, 12 Eastern. Sorry, I'm on Central Time, so I'm trying to do the time.
That's okay. That's all right.
But yeah, thank you very much for coming on. I'll give you a chance to, if you have any parting thoughts or any final things that you want to say, or to the audience, if you want to ask any last minute questions before we bounce, now's the time.
Yeah, last call for questions. But if you have questions and you didn't get to ask them here, you can reach out to me. I'm on most social media with the handle that I put on screen, as well as LinkedIn. So you're more than welcome to message me with a question. I'm happy to answer. And if there is anything you want to see about the HashiCorp products and OpenShift and or anything else, feel free to always let me know. I'd love to hear your thoughts and ideas.
Awesome. Well, thank you very much for coming on. Thank you. This is our 150th episode. So like it's a big deal that we got to 150, and it's a big deal that you joined us today. So thank you very much for coming on. I really do appreciate your time. And I love getting all the questions from the audience because it makes these things fly by, but it also makes it like really exciting because I get amped up when we start talking about nerd stuff, and it's cool to be able to like just sit down and like hear their questions and then come up with my own questions. So no, thank you for coming on. Thank you to the audience for your interaction today. We really appreciate it.
Yeah, thank you very much.
All right, awesome. And we will see you next week.